Right on the topic, moving charges and magnetism. Right on the first topic, when a charged particle is placed in magnetic field, when a charged particle, when a charged particle, when a charged particle, when a charged particle placed in magnetic field. So magnetic field usually represented by the letter B. Okay, magnetic field B. Charged particle placed in a magnetic field B. That's the first topic. So under this, the first point, the force experienced by the charge, the force experienced by the charge, the force experienced by the charge, F is equals to Q V B sin theta, Q V B sin theta. Q is charge, Q is charge, B is magnetic field, B is magnetic field, and V is the velocity of the charge, V is the velocity of the charge. So in vector form it is nothing but F is equals to Q times V cross B. This is the other formula. F is equals to right on the next point. V is perpendicular to B. V is perpendicular to B. So if V is perpendicular to B, it is the maximum force experienced, because sin 90 is 1. When we are talking about V is parallel or anti-parallel, it will be 0 or 180 will get. So the value of sin 0 or sin 180, it is 0. Okay, only sin 90 will get the maximum. So at perpendicular, V perpendicular to B will get the force maximum. Done. The next point, when charge is at rest, 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 F is equals to 0, F is equals to 0. So if charge is at rest, in the sense obviously velocity will be 0, so something multiplied by 0, I will get the value of 0. Charge is not 0, because charge is having a value 1.6 into 10 power minus 19. I can't say that charge is 0. charge is at 0, means like V is 0. Okay, write on the next point. When charge is moving, which means V is equals to 0 or not equals to 0? Not equals to 0. Okay, charge is moving, but I need to get the force as 0. How can I get? I told the conditions, either theta can be 0, 90 or 180, and the second condition, charge is moving or charge is at rest. So charge is at rest in the sense, obviously force will be 0. Now charge is moving, but V is not equals to 0, but I need force as 0. Then how can I get force as 0? Theta is equals to 0 or theta equals to 180 degree. Okay, write down. So charge is moving, V is not equals to 0, and the angles are theta is equals to 0, comma 90, comma 180. Right, empty. 0, comma 90, comma 180. For 0 and 180, force will be 0. For 0 and 180, force will be 0, and for 90, force will be maximum. 0 and 180, force will be 0, and for 90 it is maximum. Done. Write on the next point, like the next subheading. Arc shape conductor. Arc shape conductor. Wait here, right, change the topic, no? Change the topic. When a charge moves perpendicular to B, change the topic as when charge is moving perpendicular to B. When charge is moving perpendicular to B. When charge is moving perpendicular to B. Write down the first point. It takes a circular path. It takes a circular path or it follows a circular path. It takes a circular path or it follows a circular path. The next point, to find the direction of force, magnetic field, to find the direction of force, magnetic field or velocity. We will use left and thumb rule. We will use left and thumb rule. Okay, so usually we will use these three fingers, the first thumb finger, index finger and the center finger. Okay, so first thumb finger denotes that force, thumb finger denotes force, index finger magnetic field, index finger magnetic field, and the center finger velocity of the charge, and the center finger velocity of the charge. So how can you remember is like father, mother and child, F, M, C, force, magnetic field and the velocity of the charge, okay, or current you can take it, okay. Next point, note point you can write, note point. I will write directly the formulas of the radius, like we are talking about the circular path, no. So how much radius it has been taken, I will write the formula, like I am not deriving anything here. So R is equals to MV by QB, MV by QB. So R is the radius of the circular path, R is the radius of the circular path. So what is the term mass and velocity denotes? Momentum, right? Yes, no? Can I write like R is equals to P by QB? Take down. This is in terms of momentum. So if we want in terms of kinetic energy, then how can we convert? What is the relation between momentum and kinetic energy? Kinetic energy is equals to P square by 2m, no? So can I write like this, 2m times kinetic energy, it is in under root, will be equals to P. So can I substitute this value here now? So R is equals to root over 2m into kinetic energy by Q times B. So radius in terms of mass and velocity, radius in terms of momentum, radius in terms of kinetic energy. Take down. Write on the next point. Since it is a circular path, since it is a circular path, since it is a circular path, the relation between velocity and angular velocity, the relation between velocity and angular velocity, V is equals to R omega, V is equals to R omega. So from this I can write omega is equals to V by R. So what is R here? mv by qb. So I can write V by mv by qb. So V and V will get, V will get cancelled and qb by m. So this is in terms of angular velocity. If you want in terms of velocity, I can rearrange this one as V is equals to R times QB by M. So this is in terms of velocity and this is in terms of angular velocity. So time period t is equals to, next point, time period t is equals to 2 pi m by qb, 2 pi m by qb. Time period t is equals to 2 pi m by qb. Frequency f is equals to, it is 1 by time period, so reverse this one, so qb by 2 pi m. Okay, right on the next point. So charge moves with an angle with respect to b, an angle with respect to b. Charge moves with an angle with respect to b. So we were talking about the angle 0, 90 and 180. Now we will talk about the angle which is not equals to 0, not equals to 90 degree and not equals to 180 degree. So if these three angles are not taken, then the path will be helical path. Right now, if theta is not equals to 0 degree, not equals to 90 degree, not equals to 180 degree, if theta is not equals to 0, 90 or 180, then the path will be helical path. The path will be helical path. Helical is nothing but it's like a spiral. This is the path. Right on next subheading. Force between two straight parallel conductor. Force between two straight parallel conductor. Force between two straight parallel conductor. Take the diagram and let me take the distance between them as r. Force between two straight parallel conductor. Right on the first formula, force per unit length, force per unit length, force per unit length, force per unit length. So F by L is equals to mu naught, F by L is equals to mu naught by 2 pi, F by L is equals to mu naught by 2 pi I1 I2 by R, I1 I2 by R. The next formula is force. The next formula is force. So force in the sense I need to consider this L in the other side, that's it. F is equals to mu naught by 2 pi I1 I2 by R into L. So under this the application, under this topic the application. The first point, current in the same direction, current in the same direction they attract each other, current in the same direction they attract each other, they attract each other, current in the same direction they attract each other. The next point, so obviously the vice versa, current in the opposite direction they repel each other, current in the opposite direction repels each other. Done. Right on, next topic. Torque on a loop, torque on a loop placed in magnetic field, torque on a loop placed in magnetic field, torque on a loop placed in magnetic field. So tau is equals to m cross b, tau is equals to m cross b, tau is equals to m cross b. So what is the torque we have learned in the electric fields? Tau is equals to Pe sin theta. Like what is P there? Electric dipole. Here M is nothing but magnetic dipole. Write down, M is nothing but magnetic dipole. So there we are talking about the electric field, here we are talking about the magnetic field. So obviously the formula will be Mb sin theta. So we will learn about what is the magnetic dipole in the next lesson, magnetism and matter. Right on the next topic, moving coil galvanometer, moving coil galvanometer. Right on, magnetic moment M, magnetic moment M is equals to NIA, NIA. So N is nothing but number of turns, N is nothing but number of turns, I is nothing but current, and A is nothing but area of cross section. So for application purpose you can write that A in terms of pi r square. Okay, most times we will use in the question area as pi r square. Write on the next topic. Biot-Savart's law. Biot-Savart's law. Biot-Savart's law. Biot-Savart's law. So whenever we are talking about Biot-Savart's law, right and thumb rule. Okay, right and thumb rule we'll use here. Okay, you can mention there. We'll use right and thumb rule. So for the force we are using the left hand thumb rule. Okay. So what is the thing is, the thumb finger denotes the current and the curl finger denotes the magnetic field. Okay, if the current is in upward direction, the magnetic field will be inside. If the current is in downward direction, the magnetic field will be outside, like depends upon the thumb where it is showing. Okay, if it is upward, so it is inside, like my thumb is denoting inside. If it is downward, my thumb is, the palm is denoting outside. It's not thumb, the palm. Okay, write down. B is equals to, magnetic field B is equals to mu naught by 4 pi into I into dl sin theta by r. Magnetic field B is equals to mu naught by 4 pi I dl into sin theta by r. Write down the value. Mu naught by 4 pi is equals to 10 power minus 7 Henry per meter. Henry per meter. Mu naught by 4 pi, the value is 10 power minus 7. If they are asking what is the value of mu naught, it is 10 power minus 7 into 4 pi. Write down. Mu naught is absolute permeability. It's absolute permeability. In bracket we can write, like when we are measuring in vacuum or air. Measuring in vacuum or air. Second one is mu. So mu is nothing but permeability of a medium. Permeability of a medium. So mu naught is permeability of a, like absolute permeability, it is permeability of a medium. Okay, and it is the relation between, write down, the relation between mu naught is given by, mu and mu naught is given by mu r is equals to mu by mu naught. Mu r is equals to mu by mu naught. It is relative permeability. It is relative permeability. R is nothing but, like mu r is nothing but relative permeability. Done. Write down the applications. Application 1. Application 1. Straight conductor. Application 1, straight conductor. So under this, the first one is infinite length. The first one is infinite length. So formula is B is equals to mu naught by 4 pi I by r into sin alpha plus sin beta. B is equals to mu naught by 4 pi into I by R into sin alpha plus sin beta. So I will draw the diagram here for a finite. So current is going in this direction. I am measuring the current from a point P, the distance is R. So if I take the angle, so this is alpha and this is beta. So this is the diagram. Second, under this second one, application, under application 1, second one. So first is infinite length, the second one is, first one is a finite length we have written, no? Infinite, like change that as a finite, it's a finite. Alright, just erase in, that's it. Strike out. Now it is a infinite length. Now it is an infinite length. So it's when it's an infinite length, no, like the length will be keep on increasing. So angle will be equals to 90 degree, which means tends to 90 degree. So if I take the angle as 90, what happens here to the formula? Sin 90 plus sin 90, 2 I will get. So the value I will get is B is equals to mu naught by 2 pi I by R. This is the formula for infinite length. Okay. Application 2. Suppose if it one side is a finite and one side is infinite, what happens? One side is finite and one side is infinite. Sin alpha plus sin 90 or sin 90 plus sin alpha, whatever, or sin beta we can write. I will write the formula here. Either if I take this as infinite and this as finite, this is beta and this is alpha, so alpha will be 90 and beta will be as it is, beta only. Okay, I will take, and what happens here? It is sin 90 and here sin beta. Suppose if I draw the diagram, it is infinite and this is finite. So alpha will be there and this is beta will be there. So beta will be 90 degree. So B will be equals to mu naught by 4 pi. It is I by R into sin alpha plus sin 90, and for this it is B is equals to mu naught by 4 pi I by R into sin 90 plus sin beta. Take down. నీట్గా రాయలేదు. For a circular conductor, circular conductor, circular conductor. Write down the formula. Yeah, application 2. B is equals to mu naught n I r square by 2 times of r square plus x square power 3 by 2. So this formula is for axial point, axial point, axial point. So the diagram will be looking like this. Take the diagram. If x is equals to 0, if x is equals to 0, if x is equals to 0, then what happens to the formula? B is equals to, and this one will be 0, no? So power 3 by 2, 2 will get cancelled off, and 2 r's will get cancelled off. So B will be equals to mu naught n I by 2r. This is my formula when x is equals to 0. Now you write the topic, arc shaped conductor. Arc shaped conductor. Arc shaped conductor. ముందే స్ట్రైక్ అవుట్ చేసినారు కదా అదే arc shaped conductor. So formula is B is equals to mu naught by 4 pi I by r times theta. So it will be looking like a arc which makes an angle theta and the radius is r. Write the point. Seven. Write down. Theta must be in radius. First point is theta must be in radius. Theta must be in radians. So radians, not radius, radians. So for example, 360 degree is equals to 2 pi. For example, 360 degree is equals to 2 pi. 180 degree is equals to pi. 90 degree is equals to pi by 2. 60 degree pi by 3. 45 pi by 4. 30 pi by 6. Write on the application. Write on the application here. So whatever I am drawing, no, try to draw it as it is. Take these diagrams. Write the first point. When the point is on axis, when the point is on axis, when the point is on axis, the magnetic field will be 0. When a point is on axis, the magnetic field will be 0. So B1 equals to 0 here, B3 is equals to 0, and B2 will be mu naught I by 4R. So it is into the field. So B net will be equals to B1 plus B2 plus B3. The next diagram is so B is equals to mu naught I by 4R. So B is equals to mu naught I by 2 pi R. So for this, try to remember the diagram and try to remember the formulas. They might ask the direct question on this. Direct questions are there in this diagrams. So what are write on the next topic if you have completed the last topic. On the topic Ampere's circuits law. Ampere's circuit law. Ampere circuits law. Ampere's circuit law. So it's just like a Gauss law only. So what is the Gauss law formula we have learned? Integral E dot dl or E dot ds is equals to q in by epsilon naught. Yes, no? So similarly here the formula is integral b dot dl is equals to mu naught I. Mu naught I. So here also I whatever present inside the system only we are considering, not outside the systems. So suppose if they have given the direction of the current inside, I should consider as a negative, outside it is positive. Inside means nothing but it is cross mark, outside means a dot. Suppose if there is a system, so I will take 3 currents and outside 2 currents. So this is I1, I4 and I3, and this is I2 and I5. Okay. Now if I want to find what is the magnetic field, so integral B dot dl is equals to mu naught times minus I1 plus I3 plus I4. I told you that cross denotes that, minus, dot denotes plus. You can take this one. Completed? So under this subtopics, solenoid and toroid, solenoid and toroid, solenoid and toroid. So for both of them the formula is B is equals to mu naught n times I, mu naught n times I. Write down. N is equals to number of turns per unit length. N is equals to number of turns per unit length. So N is equals to capital N by L. So the formula will be B is equals to mu naught Ni by, capital Ni by L. So for solenoid we will use the same formula, but for the toroid we will use B is equals to mu naught N I by 2 pi r. Instead of L, 2 pi r. So for solenoid, no, it will be like a circular strings are there. For toroid, I will take that circular string in terms of a circular path only. So this is my toroid and this is my solenoid, the length, and this is the radius.